So to recap everything we have discussed in these 4 lectures, we start out these really basic questions a little kid might have had by looking up the sky. How did this big universe begin? And we talked a lot about this. For example, inflation started out incredibly tiny universe into a macroscopic universe as we see today, and that inflation flattened the universe out as we see today. Also made the temperature the same throughout any directions you look at, but also at the same time planted the seed for structure formation later due to this quantum noise that happened in this microscopic world due to uncertainty principle. Dark matter was also responsible for studying the beginning of the universe, and Higgs boson as well, and also the absence of antimatter. What is its fate? The dark energy has a lot to it. Dark energy is accelerating the expansion of the universe, and depending on the nature of dark energy, we talked about this equation of state parameter, dark energy may keep multiplying to the extent that it may lead to an end of the universe, or maybe it may go back to decelerated universe, like what it did with inflation. It may be the second round of inflation in a way. So that has to do with the nature of dark energy. What is it made of? We have seen the energy budget. What we thought the universe was made of, namely atoms, turned out to be actually a tiny fraction of the universe, less than 5%. The rest was dark matter, about a quarter of the universe, and dark energy, about 70% of the universe. So what it's made of has very strong link to how the universe began and how the universe is going to end up with. What are its fundamental laws? We talked about the theory of gravity due to Einstein, that gravity was sort of an illusion. Gravity is about the warping of space and time. We still don't know much about the fundamental laws of physics. If you go all the way back to the beginning of the universe, maybe we have to replace Einstein's theory and everything else we know by a new theory of physical laws. We don't know that. So that's something we're pursuing at the same time. And also, where do we come from? We talked about the origin of chemical elements that make up us, and that partly came from the formation of bigger elements inside the stars that got released into outer space by the supernova explosions. And also the atoms need to have electrons going around that would require Higgs boson filling up the entire universe. We also need to get rid of antimatter so that we can live happily without fear in the current universe. And all of these things come together into the same question about the universe, and that's something that is really coming into the realm of science. I hope you got that message clearly. So it's really interesting to think of the universe in terms of this snake of sizes. So we are here, and we have the size of, let's say, 1 meter or so. If you're going up to bigger sizes, you may see a mountain, Earth itself, solar system, and galaxies, and eventually go to cluster of galaxies to the entire universe. And that's the biggest thing we can see and think about. On the other hand, if you go to smaller and smaller sizes, well, human body may go down to cells, DNA, eventually to atoms, nuclei, and elementary particles. That may go back all the way back to some kind of a unified theory that describes all the forces and all matter particles at the same time. And it so happens that this world of tiny, tiny things, where the quantum mechanics is really the laws of physics, creating these uncertainty principles, turn out to be the origin of all these big structures in the universe today because of inflation. So big things and small things actually come together. And this is really nicely represented by this picture of Ouroboros snake from Greek mythology that was meant to represent the unity of the world. And indeed, unity of the world today is about the entire universe and the smallest particles we can think of, and they actually come together. Is a very, very interesting observation. So in terms of the scales of object, biggest things and smallest things come in hand, and unless we actually think about them together, we can never comprehend the mystery of the universe. So that's how I started this institute called Kavli Institute for Physics and Mathematics of the Universe at the University of Tokyo. As the name suggests, we'd like to study the universe by a combination of physics and mathematics, and obviously astronomy comes together too. And we started actually from scratch back in 2007. that was founded completely new, where nothing existed before. A year later, we grew to this size, and I hope you've seen that we have very international composition of our membership. 2 years later, 3 years later, 4 years later, 5 years later. So this is where we are. And the composition is more than half international, even though this is an institute in Japan. So that is the Institute for the Physics and Mathematics of the Universe, thanks to Kavli Foundation in the United States that created some endowment for us. We are now Kavli Institute for the Physics and Mathematics of the Universe. This is where we study all of these questions we talked about in these 4 lectures. I hope you would be interested in coming to visit, may even join a membership at some point. Thank you for your attention.